Okay, so today is our second session. So if there are any questions, you can ask me via chat, or also you can unmute yourself and ask questions, any questions. So this is live and interactive class. If there are any doubt points, or if there are any things that is been discussed in the class or outside the class, it can be inorganic or anything, you can ask from me. We can clarify the doubts. So to start, let me share the screen. Last week I gave you some homework as well. Nevertheless, I will start from this one actually. If I explain how the class goes on, you can the Tuesday class. Our Tuesday class is mainly focusing on organic. I will going through organic questions, organic synthesis, organic conversions, and mainly focusing in organic. And also gradually I'll be focusing on inorganic cation analysis as well. This cation analysis, I mean the seventh question, inorganic question, not from that physical chemistry part, that which comes from inorganic part. That flow charts are the identification. What is this one? What is this one? You have been given with the colors, and you have been asked to write down the reactions and everything. So I will be focusing on those questions as well, because those are questions high marks with carrying high marks. So you can focus on those things and get clarified during the class as well. In initial days of the class, I will be giving you the questions at the class itself. Then when the students are settled, when we have a permanent batch of students, I will form a group, and I can share a soft copy or printed copy with you guys. Then we can focus on that part, right? Okay. So let's start the proceedings for today. To start with, I asked to do this conversion within 5 steps. I got some answers as well. By the way, uh, if you join to our WhatsApp group, or if you are with our Telegram channel, you have my number, right? So this is my number. I'm on this number. What my WhatsApp number is also the same number, so you can share me any questions, or if there are any homeworks, you can just send a WhatsApp to me, then I can check, right? Even though I'm not replying, I'm checking your answers, and if there are anything special thing to be notified, I will tell you. But however, I will be reading each and every message, and I will be replying each and every messages as well, right? So if there is any homework, you can send it to group, or like you can directly send it to my number as well. Okay. All right. So how to do this question in 5 steps, right? So we have to create a triple bond here. With me, you can try, right? So if you have not done this question, by the way, I have opened my chat window as well. I can see the chat, and I have my phone as well with me. Then you can ask any questions. During the class, I will not check on the WhatsApp actually, but you can send me the questions and answers. Then I can check the questions and the answers after the class, which you have sent to Telegram or WhatsApp. You can use Telegram as well. I have Telegram and WhatsApp. I'm using both. Uh, if you want to call me after 5 p.m. I will answer. Okay. All right. So to do this question, first of all, I need to create a triple bond, right? So in order to create a triple bond, I need to get rid of this OH bond, and I need to when I get rid of the OH group, I will have a double bond, right? So how to get rid of OH is, I have explained in the last week. We can use three regions. One is concentrated H2SO4, anhydrous Al2O3, or just Al2O3 while heating, and P2O5. Commonly we use concentrated H2SO4 while heating, right? So we can use concentrated H2SO4 while heating. Then we have the double bond. OH group will be selecting the hydrogen atom from the neighboring carbon atom, not from its own carbon atom, neighboring carbon atom. I have explained this one in the last week. So if there are two carbon atoms, two neighboring carbon atoms for the OH group, it will select the hydrogen atom from the least number of hydrogen atoms, carbon atom which has the least number of hydrogen atoms, right? So that is the basic theory of removal of OH group with hydrogen. Hydrogen will be selected from the first theory is hydrogen will be selected from the neighboring carbon atom. If there are two neighboring carbon atoms, it will select the carbon atom with least number of hydrogen atoms, right? ගලවගෙන යනකොට අඩුවෙන් තියෙන තැනින් තමයි ගලවගෙන යන්නේ. That is the nature, right? So it will apply for chemistry as well. So we will have this one CH2, there will be no change to here, and hydrogen atom will be going through or taken out from this carbon atom, then double bond will be created and CH2. If somebody can't understand this one, there's a question actually. Can we use HBr to remove OH minus? No, you can't use. That means it. You can use HBr, but it will take two steps. But I want to remove OH group from one step actually. HBr is not a suitable one for this one, right? So මේක උනේ කොහොමද කියලා තේරෙන්නේ නැත්නම් මේක වෙන්නේ මෙන්න මේ වගේ වැඩක්. CH3 CH2 then CHH and CHOH NH. So hydrogen will be selected from the neighboring carbon atom. So it will club with like this and it will select the hydrogen atom from the neighboring carbon atom, and these two will be removed. Instead of these two, pi bond will be created in between, right? Is it clear? Any questions on this one? How to remove or how on the removal of the H2O molecule? මේක තේරුම් ගන්න ඕන දේ තමයි OH group removal means it is a H2O molecule removal. H2O molecule removal means you can use those three regions. In your scope, only those three regions will be used. Okay. Then after that, I need to convert this double bond into triple bond. Right. There are many ways. I have explained this one last week as well. So I will add Br to CCl4 through the double bond, right? Then we can create a triple bond. Now let's see what will happen when we add Br2 at this stage. Right? මෙතනදී දාපුවම මොකද වෙන්නේ කියලා බලමු පොඩ්ඩක්. හරිද? Now එකපාරම දැන් මම ගිය පාර කියලා දුන්නානේ to convert into double bond into triple bond, you can use Br2 or OH minus addition or chlorine addition, something like that you can do, right? So you can check whether this will work, like if Br2 is added at this point. මෙතනදී බලන්න පුළුවන්. හරිද? අපි බලමු මේකෙදි මොකද වෙන්නේ කියලා. Yes, that's a good question. Can we use HBr for this step? That is the answer that I need. I need to show if I use Br2 at this stage. right? එතකොට මොකද වෙන්නේ කියලා බලන්න. හරි. එතකොට දැන් ඩබල් බොන්ඩ් එක දැක්ක ගමන් ට්‍රිපල් බොන්ඩ් එකක් හදන්න ගියොත් එහෙම මොකද වෙන්නේ කියලා බලන්න මෙතන. හරිද? So we will have end result here CH3 CH2. Here this is not C actually, this is CH because one hydrogen atom is remaining here. CH CH2 and Br will be added here. So when we try to remove Br, triple bond will be created in here, in between these two. But we need the triple bond in between these two actually, the yellow highlighted one. So therefore we need to shift the double bond. To do that we can, as correctly mentioned, we can use HBr for this step. එහෙනම් double bond එක දැක්ක ගමන්ම triple bond එක හදන්න Br2 දාන්න යන්න එපා. Don't do that. If you have to shift it, add HBr or H2O molecule. දෙකක් ගන්න වැඩ දෙකක් කරන්න පුළුවන්, right? So I will add HBr, right, for this one. මේක තේරෙන්නේ නැත්නම් අහන්න ඕනේ. I will add HBr for this one. Then it will be having something like this CH, Br, CH3, right? So yes, is there any question? No, right? Then I can remove bromine again, right? By using the same, by using, how to remove Br? What is the region that we can use? I need to remove this Br. How to remove this one? Any answers? You can, yes. Yes, correct. Yes. Good. Yes, yes, yes. Okay, correct. So you can use alcoholic KOH. Yes, correct. Many answers. You guys are very good. You are on track. Very good. Maybe there is a number. Okay. So we can use simply alcoholic KOH and we can heat, right? So heating also will remove hydrogen, as I explained in previous step. It will not remove the hydrogen from here, but it will remove the hydrogen from here, because it is selecting the hydrogen atom from the neighboring carbon atom which has least number of hydrogen atoms. So blue highlighted one will be selected for the hydrogen removal, right? So then it will be CH3 CH double bond CH CH3. Now you can see, then this step I can add OH minus ions or I can add Br2. Now up to now we have completed 3 steps as well. Step we have to do it in 5 steps, right? So I think you can see the goal now. I will add OH minus MnO4 minus ions, right? O Br2 CCl4, right? Then this will become CH Br CHBr CH3. Then I will remove HBr, alcoholic KOH, right? Or you can say ethanoic KOH. No, simply you can say alcoholic KOH, right? Alcoholic KOH. You need to remember, you need to heat as well. So if you need to count the steps, count the arrows that you have drawn. 1, 2, 3, 4, and 5. 5 steps has been done, right? So this is how you do this question. Any questions? That's a question. When we adding Br2, is it a must to add CCl4? Yes, we need to add CCl4. Why is that? What is the reason? Anybody who can answer for this one? The question is, if I repeat, when we adding Br2, is it a must to add CCl4? Why we add CCl4? What is the reason? Can anybody answer for this one? Okay, good question. Is it a catalyst? As a catalyst. Okay. Any answer? Any other answer? Anyone else to answer this? Good question. This is not a catalyst actually. What is a catalyst? CCl4 will not act as a catalyst. What do you mean by a catalyst? What is the characteristics of a catalyst? තාම කරලා නැතු අනේ ඔයාලා කරලා තියෙනවා. I think you guys have done, most of you have done chemical kinetics, right? Yes, answer. Substance to use increase the rate without net consumption. If I, yeah, okay, that's answer is partially correct. There's answer substance used to increase rate without net consumption. Partially correct. Any other answer? Try another, yeah, correct. On class again. Okay. Wait, okay. If you have any questions, just okay. If I repeat it, substance used to increase rate without net consumption. That is the answer that I get from the class, not my answer. That is partially correct, right? Okay. So actually, this answer is 75% correct, but catalyst should involve in the reaction during the reaction, but at the end of the reaction, it should be reformed, it should be regenerated at the end of the reaction. Catalyst should be involving in the reaction, right? It makes an intermediate here. It makes an intermediate involving the catalyst as well, right? So CCl4 in this reaction does not involve, right? So therefore, it is not a catalyst actually. It does not involve. Can you remember? I will explain the. Okay. Can you remember the mechanism of this one? The Br addition, Br2 addition to an alkene. Can you remember the mechanism? If you can remember the mechanism, then it's easy to understand, easy to answer this one, right? So in the first step, let me draw the mechanism, right? Oops. Let me draw like this. Class එකේ අපි සියලුම දේවල් තියරි මතක් කරගෙන කොහොම කරගෙන යමු. ප්‍රශ්න ඕන එකක් අහන්න. That's good, right? So we have an attack here. Due to that, this will be polarized like this. And there will be a catalytic cleavage towards this bromine atom. Then we have H2C. This pi bond has been broken. then H2. This will induce a positive charge because it has lost one electron. Bromine will add here, right? Then there are lone pairs with this bromine atom. This one will donate a lone pair towards this carbon atom. So as a result of that, bromine will induce a positive charge. This carbon atom will induce a negative charge. And this carbon atom, this bromine atom will be converted into Br minus. So the net reaction after this one, or the intermediate products after this one, will be H2C, CH2, and bromine is in a cyclic structure, right? And we have a Br minus as well. This cyclic carbocation, this is called as a cyclic carbocation. It's a carbocation, cyclic one, highly unstable. Since this is a cation, since this is a cation, any anion inside the medium can attack to this point, can attack to this cation as a nucleophiles, others will attack to here. If there are any other nucleophiles, they will be candidates to attack this cation. If I want to keep only Br minus inside the medium, then I need to add Br2, not in the aqueous medium. If it is an aqueous medium, we have OH minus ions inside the medium, then OH minus ions will attack here. I don't need to do this one. If it is bromine dissolved in NaCl, I will have Cl minus ions inside the medium. I don't need to attack Cl minus to here. Otherwise, the end result will not be two bromine atoms. One bromine atom and one chlorine atom. Like that. So in order to have only the Br minus ions inside the medium, and in order to make sure only Br minus ions will be attacking to this nucleophile, this carbocation, to this electrophile, we need to make sure only Br minus will be there. Then we are applying Br2 with CCl4. That is the idea, right? So that's why we need to apply this thing with Br2 and CCl4, sorry. So this will be attacking to here, and this will be cleavage towards this bromine atom. Then we have Br added to this carbon atom, H2, oops, H2, and this will be added to this bromine atom. So imagine that we have aqueous medium here, then OH minus will be there inside the medium, and it will be attacking to this carbocation. Then this will attack to here. Oops, not to the hydrogen atom, but to the carbon atom it will be attacking. This will be cleavage towards this direction. Then we will have something like this. Not the expected result. So that's why it is mandatory to apply CCl4 with Br2. Okay. So if I ask a question like this, why CCl4 is used with Br2? Why not any other component? What is the why CCl4 is suitable to apply with Br2? What is the reason? Anybody? You can unmute yourself and answer. You can type. My question is, why CCl4 is a candidate to apply with bromine? Anybody? Right. Now, if I explain it, you need the knowledge of inorganic actually, not inorganic chemical bonds. Br2 is an unpolarized molecule, right? Can you remember? Br2 is an unpolarized molecule. Non-polarized molecules are not dissolving in polarized solutions like water. Non-polarized molecules are dissolving in non-polarized solutions. So CCl4 is an unpolarized solution. Yeah, CCl4 is an unpolarized solution. So therefore, Br2 is dissolving in CCl4 because Br2 is also an unpolarized molecule. CCl4 is also an unpolarized molecule. Non-polarized and unpolarized will dissolve each other very thoroughly. Br2 is not dissolving in water because water is polarized. Br2 is non-polarized. That's the reason. Okay. So that's why we are using CCl4. Can we use CBr4? CBr4 and Br2 instead of CCl4 and Br2? For this reaction, can we use? Yes or no? මම ප්‍රශ්න අහනවා වැඩි කියලා මම ප්‍රශ්න අහනවා කාන්ට් කියලා උත්තරයක් ආවා. මොකද අනිත් කට්ටිය හිතන්නේ? ප්‍රශ්න අහනවා වැඩි කියලා හිතන්න බෑ මට මම ප්‍රශ්න අහන්නේ ඇත්තටම ඔයාලා ඔයාලගේ දැනුම ටෙස්ට් කරන්න නෙමෙයි just I need to interact with you. That's why. What do you think? Can we use CBr4 instead of CCl4 with Br2? Answer is can. Why? The only reason that we use CCl4 with Br2 is to provide a neutralized medium and also to dissolve Br2 to react with the alkenes. So CBr4 is also providing the same, both of them. It provides a medium to dissolve Br2 and also it provides a neutralized medium as well. So therefore you can use CBr4 as well instead of CCl4. Okay. Right. Right on this question. This question. Mami තනිකර organic deep discussion එකක් කියන්නේ ඔයාලා කරපු දේවල් වලින්. Not only the questions I'm discussing. So if you need to write down or short, take some short notes or something like that, take them by your own. Then you can add these things, add small notes to your theory notes as well, which we are discussing, right? So my goal is to brainstorm organic with you guys, right? And to prepare you guys for the organic question, right? මගෙත් එක්ක සති 10ක් 15ක් විතර අපි මේ වැඩේ කරොත් this is a free of charge class. ඕන කෙනෙකුට එන්න පුළුවන්. Then you got the
solid එකක් නේද?
CBr4 solid එකක් නේද? Good question. CCl4 is also solid පුතා. CBr4 is also solid. CCl, but both of them can be converted into liquids. So therefore, CBr4 has to be used in liquid form in this reaction. It's a solid, so it has to be converted into a liquid before react before involving in this reaction. CCl4 is also solid after beyond 35 degrees Celsius, if I am not mistaken. Liquid එකටම දාන්න ඕනේ. Okay?
Okay, sir. Thank you.
Yeah. All right. Good question. මම තමයි ඉන්න ඕනේ. කසිලම දුවමු අපි. Very good. මේ ගාන කරමුද අපි? කරන්න බෑ. By using CH3, CH2, Cl and alcoholic KOH, by using CH3, CH2, Cl and alcoholic KOH are the only organic compounds by using CH3, CH2, Cl and alcoholic KOH as the only organic compounds, not other, as the only organic compound. Synthesis CH3, CH2, 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 CH3 in 6 steps. දැන් මේකේ කතන්දරය මේකයි. You can use any other reagent which are inorganic, right? The condition is if you are using an inorganic reagent for this synthesis, it is only CH3, CH2, Cl and alcoholic KOH, because alcoholic KOH is also inorganic, but alcoholic means it's organic, no? So alcoholic KOH and you are allowed to use CH3, CH2, Cl and alcoholic KOH as the only organic reagents. You can use any other inorganic reagents, but other condition is only in 6 steps. හරි කරන්න බලන්න. හොඳ ගානක්. හරි හදපු එකක්. ඔය තියෙන WhatsApp වලින් very good එක. හොඳට හදලා තියෙනවා. Good. Okay, I will repeat the question, Pata. Yes, good. I can repeat the question. By using CH3, CH2, Cl and alcoholic KOH, මේ මාව කැඩනවා නම් කියන්න. කැඩනවා නම් කියන්න. CH3, CH2, Cl and alcoholic KOH by using CH3, CH2, Cl and alcoholic KOH as the only organic components, as the only organic reagents, or as the only organic compounds. synthesis, CH3, CH2, 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 CH3, this one, which is yellow highlighted in 6 steps. Yes, good. Niyman. පුතා නමක් දාන්නවද දැන් ඔප එක්කන? මේ කට්ටිය නමක් දාන්න මට චුට්ට. එලකිරි. හරි. මේක බලමු. That's a question. It means we need to convert CH3, CH2 into one. Yes, you need to convert CH3, CH2, Cl into the one which is mentioned. Right. Okay. Very good. Bye. Yeah, okay. තව කට්ටිය ඉන්නවද? මම උත්තර දෙනකොට නමත් එක්ක එවන්න. මට ඒතර ඔයාලා අඳුර ගන්නත් පුළුවන්. අර කලින් මේ පුතාගේ නමත් එවන්න පුළුවන්. පන්තිය 10යි 7ට එවලා තියෙන්නේ නමක් මේක. කලින් ගිය හෝම්වර්ක් එක මේ පුතාගේ නමත් එවන්න. Okay. Right. Got it. තා පොඩි වෙලාවක් දෙන්නන්නේ. අපේ ක්ලාස් එක now Tuesday completely on organic and we will have the class on Friday. Friday mixed exercises. ඔයාලට කරලා තියෙන පාඩම් වලින්. I know most of you have done chemical kinetics now over and organic partially done, inorganic completely done. කරලා තියෙන තැනට වෙනකන් ගණන් හදනවා. Exam type ගණන් හදනවා. MCQs, essay type questions, structured questions, new questions, past papers, everything will be done. Free class එක ඇවිල්ලා ගණන් හදාගෙන වැඩේ කොට දාගන්න. මේ 10 ඉඳන් කරන්නේ සිකුරාදා from 10 pm onwards දිගටම කරනවා. ඇවිල්ලා වැඩේ කොට දාගන්න. right. කරන කට්ටිය කරගෙන යන්න. කරලා ඉවරයි නම් වන්න මට බලන්න. මම පටන් ගන්න කරන්න. Right. Okay. Now we have to start from CH3, CH2, Cl. Sorry, yeah, CH3, CH2, Cl. Now I will remove chlorine here. Okay, Cl තියාගෙන මේක කරන්න බෑනේ. So I will use alcoholic KOH. and I will heat this one. Then I will have CH2 double bond CH2. Now, when you look at this conversion, the number of carbon atoms has been increased, right? That means initially we have two, making a monomer pattern CH3, CH2, Cl. However, you have to start from there because you can't start from the alcoholic KOH, right? So that is some hint that you need to understand. Then, if you check the end result, it has 6 carbon atoms, right? So six carbon atoms, like it it seems like if you have to use only CH3, CH2, Cl, it has to be added in 2 times. If you are starting from CH3, CH2, Cl, and if you add CH3, CH2, Cl or any other component derived from CH3, CH2, Cl, has to be added 2 times to the initial component. In your scope, that can be done through acidic alkynes. You know, acidic alkynes, you add sodium, and sodium can be attached with halohydrocarbons. So then halohydrocarbons, hydrogen atom will go with sodium and organic part will plug to the alkyne. I will convert this to an alkyne because carbon addition can be done through alkynes very easily, right? Acidic alkynes actually, not alkynes, acidic alkynes, right? So I will convert this into an alkyne. So what I do is I will add Br to CCl4, a popular one. Then we have this one. Then I will remove this by using alcoholic KOH. එකපාරම මේ කන්වර්ෂන් එක කරනකොට එක අවුරුද්දක මගෙන් පොතේ ප්‍රශ්නයක් ඇහුවා. So දැන් මේකට alcoholic KOH ඉස්සෙල්ලත් දාලා තියෙනවා. දැන් ආයෙ දානවා. ආයෙ දානකොට කලින් දාපු alcoholic KOH නැද්ද කියලා. It's a good question. I have never thought about something like that before. ඔය ප්‍රශ්නය මම හිතන්නේ 2010 වගේ 2010. මේ ප්‍රශ්නය මනුස්සයා ඉන්නේ මේ ජර්මන් වල PhD කරලා දැන් මේ ලෙක්චරින් කර ඉන්නවා. So here, don't think about like that. Just think every step as a fresh step in organic conversions, organic synthesis. Don't think like, okay, alcoholic KOH is already there, then we are adding Br2 and we are adding KOH, alcoholic KOH again. No. It's not like that. So think every step as a fresh step. Therefore, don't worry about what you have added earlier. Right? So that is the nature of the organic synthesis or organic conversions. Okay. So then this will be converted into triple bond like this, right? Then this is an acidic alkyne. What is acidic alkyne? Acidic alkyne again what is acidic alkyne? How do you identify an acidic alkyne? There are 2 types of alkynes, right? Alkynes and acidic alkynes. How do you identify acidic alkynes? Okay, correct. I will give you a question, right? Don't like something like this. Can somebody tell me whether this is an acidic alkyne? Um, is this an acidic alkyne? Yes, correct. Answers දෙකක් ආවා. Both are correct. Can you tell someone is this an acidic alkyne or not? Yes or no?
No.
Yes. Okay. No, this is not an acidic alkyne. Correct. So because acidic alkynes are defined when there is a hydrogen atom directly connected to the carbon atom which is in the triple bond. That is the idea. This is how you identify an acidic alkyne. This hydrogen atom is called as acidic hydrogen, right? Why it is called as acidic hydrogen? Because it can be removed very easily. There are 4 methods to remove this one, right? Acidic alkynes are involving in 4 reactions with sodium, with sodamide, and what else? What are the other 2 reactions that you learn in your scope? Acidic alkynes reacts with sodium, sodamide. What else? Correct. What else? One answer is AgNO3 and ammonia. What is that? New scope that you learn. Correct. Correct. You can take CuCl, ammonia. Yes, correct. Not only cuprous chloride, it has to be with ammonia. Just CuCl or Isala Gilsarki like CBr is a solid, so CuCl is also a solid, so it has to be converted into a liquid form. So that's why we add it with NH3. Can somebody tell me what is the color of CuCl? I'm trying to improve your recalling power, right? That's why I'm asking questions. Yes, correct. What's the color of CuCl? How about others? CuCl is white in color. Cu plus is, yes, correct, correct. So Cu plus is showing white white components, right? Can someone tell me what is the color of this one? Additional question. Yes, this is yellow green, right? This is yellow green. මං කට්ටියට මේ වීඩියෝ එකක් දාන්නම් මේක. Yellow green. මේක මේ පාර විභාගයට අහලා තිබුණා. Yellowම නෙමෙයි. This is yellow green, right? So additional things, right? So when sodium is added to acidic alkynes, H2 will be released. With sodamide is added, ammonia will be released. AgNO3 is added, there will be white precipitate. When CuCl is added, red-brown precipitate will be there, right? So these are the observations. What matter at the end, this has to be remembered, right? Now we have this fellow. Now what I am doing is I am adding sodium. When sodium is added, we have something like this. Sodium is added to both ends. මට ආපු එක උත්තරයක තිබුණා මේකේ මැදට ඉරක් ගහලා without showing, not this one. Yes, මේ මැදට ඉරි ගහලා අහුවෙන්න එපා. It's not an covalent bond, it's an ionic bond. So you have to mention it as Na plus C minus and C minus Na plus, because sodium is not creating any covalent bonds, it is creating ionic bonds. So therefore, this has to be ionic components, ionic compound. So it has to be mentioned like that. Now I am adding CH3, CH2, Cl to this one, because sodium can go with chlorine. Since there are two sodium atoms, 2 moles of CH3, CH2, Cl will go with sodium. So therefore, this sodium and this sodium will go with chlorine. Yellow highlighted sodium will go with chlorine, and CH3, CH2 will be added to those two positions. So we will have CH3, CH2, triple bond, CH3, CH2. So our end result is CH3, CH2, 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 Cl, sorry, CH3, which is CH3, this is CH2, sorry. So from here to here, you can use H2PT. Now here, and also you need to heat. So here the heating has to be done. Platinum is a catalyst. Here platinum is a catalyst, and hydrogen is the reagent here we use. Here the platinum is a catalyst. In CCl4, it is not a catalyst, because in this reaction, all of theory classes I haven't seen your notes actually, but remember here platinum is used as a catalyst here, right? Because it is involving in the reaction, and at the end of the reaction, it will be as it is regenerated, right? So can you remember in nitration of benzene, I think you have done this one. H2SO4 is working as a catalyst. It is involving in the reaction, and at the end of the reaction, H2SO4 is formed. So H2SO4, nitration of benzene I'm talking about, right? You are adding concentrated H2SO4, concentrated HNO3, and you are heating. So concentrated H2SO4 is in helping out HNO3 to produce NO2 plus ions. Then at the end of the reaction, H2SO4 is again formed. So therefore, H2SO4 in that reaction is a catalyst, right? So that's how you identify a catalyst. I think you have done chemical kinetics, right? All right. Next question. Make a in on a next one. Because you have done only up to as I know, most of the classes have done only up to alcohol. So alcohols is just started. So that's why. Okay. Write down this one. How do you attempt to separately identify? How do you separately? How do you attempt to separately identify? How do you attempt to separately identify? How do you attempt to separately identify CH3, CH, CH, Cl? Look at the board. I have written it. CH3, CH, Cl, CH3, and CH3, CH2, CH, Cl, CH3. How do you attempt to separately identify these two components? Explain. Try up then, give it a try. ඔයාලා ඇල්ඩෝල් සොරි ඇල්ඩිහයිඩ් කරාම කියන්න දඩ ගණන් හදන්න පුළුවන් after aldehydes. That's a question. Like, uh, can we separate them by using their boiling points? Because 2-chlorobutane has the higher boiling point than the other. Good point. Uh, okay, that can be taken as an answer. This is a physical method, no, Pata? Let's say I need to identify this one chemically. Your answer is correct. Your answer is correct, but there is no much gap. Yes, there will not be that much of gap, but still it has a difference. So if you can measure it correctly, yes, you can. But the other argument is also correct. There is no that much of gap. So how to identify, how to measure them properly? Practically, there may be some situations. So how to the measuring the small gaps. So we will say like you need to separate identify these two in chemically. මම හිතනවා ඔයාලා මේවා ගැන හදලා හදන්න ඇති හදන නැත්තම් බලාගන්න මෙහෙමයි හදන්න. හරිද? මේ වගේ ගණන්. So you are given two unlabeled samples of these two, not labeled samples. You can't identify them. So these are unlabeled samples, right? Unlabeled samples. So if these are unlabeled samples, you can't treat one bottle. Uh, you can't treat one bottle differently, right? So you have to treat both the bottles at uh, as same. Whatever you do to one question, one bottle, it has to be done to the other bottle as well. Okay, this is very good. Good. Uti namat evanna mata meke, then I can identify you, right? Just start the name as well. Right. So whatever you do to the bottle, the whatever you do to the bottle, one bottle, it has to be done to the other bottle as well, right? So what I do is, first I will add alcoholic KOH for these two, right? Right? Alcoholic KOH for these two, and I will heat. Then I will have CH3, CH double bond CH2. Then here I have CH3, CH double bond CH3. Because chlorine will take the hydrogen atom of this carbon atom, okay? The yellow highlighted one, not the other one, because it has the lowest number of hydrogen atoms. Then now I can see that the left hand side one, I can create an acidic alkyne, and the right hand one will not create an acidic alkyne. So if we can create an acidic alkyne, then I can identify these two separately, right? So I will try to create acidic alkyne from the left hand side, not from the right hand side. Right? So to do that, I will apply Br2 liquid with CCl4, then CH3CH Br, CH2Br will be there, and here I will have CH3CH BrCH BrCH3. Then I will add alcoholic KOH. Then see, I'm creating an acidic alkyne here. I'm creating non-acidic alkyne here. Now there are four methods to identify these two. You can add anything here. So I will add AgNO3 ammonia. Then here this will be white precipitate, here no precipitate. So in the examination as well, if you write down the answer in this way, this gives the explanation as well. No need to write down anything else. This is the explanation itself, right? So if there are separately identified questions in organic chemistry, you can use this method. Whatever you do to one bottle, it has to be done to the other bottle as well, right? Okay, copy this down if you need. Then I can identify you, right? Okay. Well, I think you have my number. So if you attend to the class, either you can join to the Telegram channel or you can send me your number. Then I can create the WhatsApp group. Then I can share the questions before the class as well, because I need to create a separate group which is coming to with the students who is coming to the class. So then I can share the information. But however, I will be sharing the uh, my links and everything in the Telegram group as well, Telegram channel and the WhatsApp group both. So this is completely free of charge class until your examination. I will be doing this class. Tuesday, gradually I will be converting this into organic and inorganic question class. Saturday, Friday class, I will be converting it to past paper discussions, mixed exercise discussions, and model papers discussion as well, right? Any questions on this one? Right. Next question. මේක මට කරලා WhatsApp කරන්න ගෙදරදි කරලා homework එකක් විතර මම දෙන්න. Separately identify and ch. Separately identify these two. So do this as a homework. If you have done this one before the next class, just send me the answer via WhatsApp. Now today I have done only 2 or 3 questions, but don't worry about the number of questions. You have to worry about the things that I have discussed beyond the questions. If you can't remember those mechanisms that I have explained, and if you can't remember the colors that we have discussed, CuCl and Cu enriched CuCl42 minus, those kind of things, go through them again within the day itself, right? And initially this class will be like from 10 to 11 or 11:30, something like that. This will be gradually going until 12:30 with the class goes on, right? පළවෙනිම දවසේ මම ලොකු බරක් දෙන්නේ නැහැ ඔයාලට. Then we can discuss the questions with the class goes on. So our next class will be on this Friday 10 p.m. It will be continued until 12 p.m. 12 a.m. maybe beyond that. I'll be discussing mixed exercises, energetics, gaseous questions, chemical calculations, obviously. Then inorganic questions, organic questions, organic mainly on Tuesdays. So come to that class as well. I will have added it. It's also free of charge class. So we will. I will be sharing the link with you guys via WhatsApp or Telegram. I will be sharing you the Telegram link as well. Then you can join to my Telegram channel. I will be sharing the recording as well. Recording ඕන කෙනෙක් එක්ක share කරගන්න. මේක මම free of charge කරන නිසා ඔයාලගේ යාළුවොත් එක්ක ඕන කෙනෙක් එක්ක share කරගන්න live ඇවිල්ලා you can clear your doubts and you can discuss any questions that you have, even the things that we have not discussed in the class. You can discuss with me. ඕනම ප්‍රශ්නයක් අහන්න WhatsApp කරලා ප්‍රශ්න වලට උත්තර ගන්න. I can help you, right? So let's stop the class from here for today. ඉස්සරහට තව class එක මේක තව ඇදෙනවා. පළවෙනි class ඉඳන් මම ටිකක් ලොකුවටම කරන්න යන්නේ. සිකුරාදා class එක 10 ඉඳන් 12 වෙනකන් තියෙනවා. 12 පහ වෙනකන් සමහර සිකුරාදා මම කරાવી. ඒකට join වෙන්න. I'll be sharing the recording as well. You can share the recording with your friends as well. Okay. Okay, I will stop the class from here for today. So see you on Friday, 10 p.m. Right. Thank you. Good night.